Welcome to section 5.2. In 5.2 we'll be discussing trigonometric functions. Sections 5.2 and 5.3 have an enormous amount of information all that's getting ready to get thrown at you. These two sections require a lot of memorization. If you have never had trigonometry before, you are going to have to spend a lot of time, unfortunately, memorizing things. One thing in particular is the unit circle. You're going to have to memorize this. However, if you can memorize just this first quadrant, this area, so you need to memorize all of these values in here. You should be able to figure out the rest of it if you've got this first quadrant memorized. But it is absolutely mandatory that you get this stuff memorized, or you will not be able to pass this course. So start on this today. I apologize that it's a little fuzzy right now, but you'll have a copy of this as well. I will be quizzing you on a regular basis until you have got a firm foundation of these values, and we'll be talking more about what this material means in the coming lessons. But for right now, start working on memorizing this unit circle. And there are going to be other things that you're going to have to memorize as we go along, especially in these two sections, 5.2 and 5.3. After we get past section 5.3, it's not going to be such a massive amount at one time hitting you like you're getting ready to have here. So just be aware that you've got a lot of work to do to get a good handle on this material. So let's begin by talking about section 5.2. If my camera will focus, let's see if I can help it. Alright, so in section 5.2, we're going to start by letting, this is the ordered pair xy be a point other than the origin on the terminal side of an angle theta in standard position. Excuse me. The distance from the point to the origin is r equal to square root of x squared plus y squared. So I've got an illustration at the bottom of the page. Again, I apologize that my camera's not wanting to focus, but you can look at your notes and get the same information. So what's going on here is we've got this point xy. I've drawn it over here. We're looking at the angle theta. This is in standard position because remember its vertex is at the origin. It starts from the initial side, which is on the x-axis, and goes to its terminal side, which happens to be in quadrant 2. But it could be in any quadrant. But this is in standard position. The distance from the point to the origin, from here to here, we can simply use this is the distance formula, which comes from the Pythagorean theorem, and the formula is R stands for radius, so radius would be from here to here, the square root of x squared, so this value, squared, plus height y squared. So we can use the Pythagorean theorem essentially to find the radius of this type of point. The 6 trigonometric functions of theta are defined as follows. You probably saw this at some point in high school, I would imagine. If you did, you might remember a certain way of remembering these. However, we're not ready to, if you happen to remember something along the lines of SOHCAHTOA, which you may have used to help you remember sine, cosine, tangent, etc., it's not going to apply in this section because we're not working with right triangles yet. That's coming up. But for right now, we've got to think of it in terms of these definitions. Alright, so the definitions tell us that the sine of theta is going to be the reciprocal y divided by the radius. So whatever the y value is for this point that I have on my on the terminal side of my angle, whatever that y value is here is going to be that number divided by the radius, and that's how sine is defined. Cosine is defined to be the x value of this point divided by the same radius. Tangent is going to be the y value divided by the x value, so this divided by this. Then we have cosecant, secant, and cotangent. Okay, cosecant is the radius divided by y. Now notice sine was y divided by the radius, so cosecant is just the reciprocal of sine. Secant is the reciprocal of cosine, so instead of x over r, now I've got r over x. Cotangent is defined to be x over y, which happens to be the reciprocal of tangent, which was y over x. You do have to memorize this. But once you've got sine, cosine, tangent memorized, the other three just come from flipping the original fractions. If you know that those are the reciprocals of these, then that'll make it easier for you to remember. And just come up with whatever you need to help you remember it. I just made up silly little phrases like SYR, sir, and then for tan, TYX, ticks. That helped me remember it. So whatever you need to do to help you remember these relationships. Okay, let's go to page 2. So in example 1, we are told the terminal side of an angle theta in standard position passes through the point 12,5. Find the values of the 6 trigonometric functions of angle theta. So if you know your relationships, if you know how sine, cosine, tangent, etc. are defined, this is not a difficult problem to complete. I'm going to draw my angle theta. So I'm told that it passes through the point 12,5. So I want to locate 12 on the x-axis and 5 on the y-axis. So somewhere out here, I'm just going to label it 12,5. And I'm just going to put this little dotted line in. Okay, this will be the y value because it's a vertical value. So that's going to be the 5. And then from here to here would be my x, which is 12. I need my radius in order to get all of these trig values. So to get my radius, I'll do my formula r equals the square root of x squared plus y squared. So that would be the square root of 12 squared plus 5 squared. This gives me the square root of 144 plus 25. 144 plus 25 is 169. And the square root of 169 is 13. So r is equal to 13. And I could put this in for my radius. My radius is 13. Alright, now, sine. We're told that sine theta is y over r. So that's going to be my y value, 5, over my radius, which was 13. Cosine theta is defined to be x over r. So that's my x value, 12, over my radius, 13. Tan theta is defined to be y over x. That's my ticks. I just thought that was easy to remember. Y is 5, x is 12, so my tan theta is 5/12. Okay, now the reciprocal of sine is cosecant. So cosecant theta I get if I just flip the 5/13, so it's 13 over 5. Secant is the reciprocal of cosine. So secant theta is equal to 13 over 12. Cotangent is the reciprocal of tangent, so it's going to be 12/5. And that's it. That's all I have to do. Okay, so these are my answers over here. Okay, I'll give you a minute in case you're still copying before I move on to example 2. Alright, example 2. The terminal side of an angle theta in standard position passes through the point 8, -6. That's ordered pair 8, -6. Find the values of the 6 trigonometric functions of angle theta. Alright, so let's draw a picture. So we need to locate ordered pair 8, -6. Well, it would be in this area. Okay, so I can sketch in my my x, so this, I guess I should have drawn my, let's draw the ray that goes through that point. Alright, so here's angle theta. It starts on the initial side, it goes all the way around to the terminal side on this line. And then I'm going to put in my x and my y values, or you can just leave it like this if you want to. But the radius, we need to find our radius, so we're going to do r equals square root of 8 square plus parentheses negative 6 square. Be careful that you put your negative inside parentheses when you square it, because this is going to come out to be a positive 36. So you've got the square root of 64 plus 36. That's the square root of 100. So r equals 10. So my radius r is 10. I can put that right there. And I'm ready to set it. I'm ready to do it. So sine theta, remember that was y over r. So y is negative 6, r is 10. I can simplify that. That's going to be negative 3/5. Cosine theta is defined to be x over r. So that's going to be 8 over 10. And I can simplify that to be 4/5. Tan theta is defined to be y over x. So that's going to be negative 6 over 8. And then that simplifies to negative 3/4. Now, I wish I had another pen. Yeah, I've got another color. So, to get the last three, again, cosecant is the reciprocal of sine, so it's going to be negative 5/3. Secant is the reciprocal of cosine, so that's positive 5/4. And cotangent is the reciprocal of tangent, so that's going to be negative 4/3. And those are our 6 trigonometric function values. Okay, let's go to the next page. Example 3. Okay, this is given to us just a little bit differently. Now we have to use a little bit of algebra to get it. It says find the 6 trigonometric function values of an angle theta in standard position if the terminal side of theta is defined by the line x plus 2y equals 0, where x is positive, greater than or equal to 0. So, what you can do here, you can just put a point in for x to see what you get for your y. That'll represent a point on your line. So let's see if I let x equal 4. If I let x equal 4, I'm going to have 4 plus 2y equals 0. And then I'm going to subtract 4 on both sides. So 2y equals negative 4. Divide both sides by 2, I get y equals negative 2. So that gives me the ordered pair. I put in 4 for my x, and I got negative 2 for my y. And now I can do it just like I did the other problems. So I need to locate the point 4, negative 2. So that would be in this area somewhere. It doesn't have to be exact. You can just kind of eyeball it. Here's order pair 4, negative 2. Remember, this point is on the terminal side of our angle theta, so we're going to draw our ray through this point. And our angle, it began at the x-axis and it went all the way around to here. And we are ready to find all of our trig values. We do need to find our radius. We still do the radius the same way. We're going to do r equals the square root of x squared plus y squared. So that's going to be the square root of 16 plus 4, which gives me 20. Now this one's a little different from the previous ones because we don't end up with a perfect square inside our radical. 20 is not a perfect square, so we're going to have to simplify this as far as possible, and we're going to have to keep it in the exact form, meaning there may be a square root still in our value here. If I simplify this, I know 20 is equal to 4 times 5. Okay, so I can say that this is the square root of 4 times 5. All right, and then I can simplify that because the square root of 4 is 2. So I've got 2 times the square root of 5 is my radius. So I can put that here. R equals 2 square root 5. And now we're ready to do all of our function values. So sine theta is y over r, negative 2 over 2 times the square root of 5. Okay, now notice you've got this square root in your denominator. Okay, we're going to want to avoid that. We do not leave radicals in our denominators of fractions. It's like leaving a fraction that's not simplified. It's just we have to fix that. So we are going to be rationalizing this denominator. However, I'm going to wait a minute because I know I'm getting ready to do reciprocals when I do the cosecant over here. And if I leave it like this first and then do the reciprocal, it'll be a little less work. So I know that I've got to come back and rationalize this denominator, but I'm going to hold off on it for right now. Now cosine theta is x over r, so that's going to be 4 over 2 square root 5. Now I can simplify these, I'm sorry. Sine theta, if I simplify that, that's negative 1 over square root 5. Cosine theta simplified is going to be 2 over square root 5. Tan theta is y over x, so that's going to be negative 2 over 4, which is negative 1/2. Okay, I still have to rationalize sine and cosine, so I'm going to put a box right here so I don't forget to do that. But I'm going to use these to get cosecant, secant, and cotangent. I know that cosecant is the reciprocal of sine, so it's just going to be negative square root 5 over 1, so negative square root 5. Secant is the reciprocal of cosine, so it's going to be square root 5 over 2. Cotangent is the reciprocal of negative 1/2. Flip that over, you get negative 2. Okay, let's go back and look at sine and cosine to finish it up now. But I did save myself a little work by doing cosecant and secant before I rationalized my denominators. So when I rationalize, how do I rationalize negative 1 over square root 5? This has to be written so that it does not have a square root in the denominator. So to fix that, I can multiply the numerator and the denominator by that square root of 5. So that's going to give me negative square root 5 over, and then square root of 5 times square root of 5 is going to give me 5. So no longer have that radical in the denominator. It's the same thing that I had here, it's just written in a different form. And then the second one, the cosine, 2 over square root 5, same thing, multiply by square root 5 over square root 5. This will give me 2 times the square root of 5. And then square root of 5 times square root of 5 gives me 5. So 2 square root 5 over 5 is cosine. And I've got all my other answers. So again, if you don't understand something, please ask me in class. If you're watching me explain something and there's something that you didn't get, put a note over here in the margin. Make a note of it and then ask me about it when you see me. But that was example 3. Okay, then we have this little note here. It says, from example 3, we were given x plus 2y equal to 0, and x had to be positive. Recall from algebra, we can write the equation in y equal mx plus b form, where m is the slope of the line. So if we solve that equation for y, we get y equals negative 1/2 x. You just subtract the x and divide by 2. So y equal negative 1/2 x, and you can see, if you think of this as y equal mx plus b form, you can see that your slope is negative 1/2. Okay, now go back and look over here. What else? Where else did we see negative 1/2 before? Remember, tangent is also y over x. That gave us negative 1/2. So slope and tangent, it's no coincidence that they're the same thing. So in general, we can say it is true that the slope is equal to the tangent of theta, and that can be used to help us sometime, at some point. So just try to keep in the back of your mind that slope is always going to be equal to the tangent of your angle theta. All right, now we've got the quadrantal angles. We talked about this in section 5.1, but here they are again. If the terminal side of an angle in standard position lies on either the x or the y axis, we call this angle a quadrantal angle. Here are some illustrations that, for example, 90-degree angles 180-degree angle or the 270-degree angle. These are all quadrantal angles because their terminal side lies on either the x or the y axis. In example 4, find the values of the 6 trigonometric functions for each angle. In part A, we want to do an angle of 90 degrees. Part B, an angle theta in standard position with terminal side passing through the ordered pair negative 3, 0. So this is the same thing that we were just doing. It's just that now they're on the x or the y axis. The terminal side is going to be on the x or the y axis. And we have a hint that states since any point on the terminal side can be used, it is convenient to choose the point 1 unit from the origin so that you have a radius of 1. So in part A, draw a picture. We've got a 90-degree angle, okay? So it's like this. So here's the initial side, here's the terminal side. We're going to choose a point on the terminal side. And we're going to follow their hint to let the radius equal 1. Okay, so this, if I think of this as, so if my radius is equal to 1, that puts me 1 unit away from the x-axis. So what is the ordered pair at this point? Well, x, if it's sitting on the y-axis, x is 0. And if my radius is 1, then that means that my y value here also has to be 1. So we've got ordered pair 0, 1, and then our radius is equal to 1. We use these values to get our 6 trig functions. So sine theta, y over r, will be 1 over 1, which is 1. Cosine theta, x over r, well x is 0, so 0 over 1 gives me 0. Tan theta is y over x. Well, y over x is going to be 1 over 0. Now, what is 1 over 0? Hopefully by this point you remember that 0 in the denominator is undefined. So this one's undefined. Okay, and remember what we said a moment ago. We said that the tangent and the slope are going to be the same. What do you know about the slope of a vertical line? We know that the slope of a vertical line is also undefined. Okay, now let's do cosecant. Is the inverse of sine. Not the inverse. Cosecant is the reciprocal of sine. So 1 over 1 is still going to be 1 over 1. Secant is the reciprocal of cosine. So if I flip 0 over 1 around, I get 1 over 0. 1 over 0 is undefined. And tan theta is the reciprocal of, I'm sorry, grab the white out. We're doing cotangent theta is the reciprocal of tangent. So if I flip this one around, I get 0 over 1, and that gives me 0. So I got sine equals 1, cosine was 0, tan is undefined, cosecant is 1, secant is undefined, and cotangent is 0. For part B, we want to find the values of the 6 trig functions for an angle theta in standard position with terminal side passing through the point negative 3, 0. So we'll draw a picture. So find point negative 3, 0. So that's going to put me here. So my ordered pair, and of course this angle is going to be a 180-degree angle, so it's going to look like this. And my radius will be 3. My point is ordered pair negative 3, 0. And I am ready to do all of my calculations. So I know that I need to do sine theta. I know that's y over x. Excuse me, y over r, I'm sorry. Sine is y over r. So that's going to be 0 over 3, or 0. cosine theta, I know that's x over r, so that's going to give me negative 3 over positive 3, or negative 1. Tan theta, I want y over x, so that will give me 0 over negative 3, which is 0. So both sine and tangent came out to be 0. And then I want to get cosecant. I know it's a reciprocal of sine. So cosecant theta is going to be 3 over 0, or undefined. Secant theta is the reciprocal of cosine. So that's going to be 3 over negative 3, which is still negative 1. And cotangent is my reciprocal of tangent, negative 3 over 0. And with 0 in the denominator, that one's undefined. So sine theta was 0, cosine theta was negative 1, tan theta was 0, cosecant theta is undefined, secant theta is negative 1, and cotangent theta is undefined. Okay, so the next page just kind of talks about something that we've already talked about. Since sine theta equals y over r and cosecant theta equals x, let me say that again. Since sine theta equals y over r, cosecant theta equals r over y, we call sine theta and cosecant theta reciprocal identities. Similarly for cosine theta and secant theta. Also, tan theta and cotangent theta are reciprocal identities. So reciprocal identities just means that if you've got one, you can easily find the other. So we have the reciprocal identities simply state cosecant theta equals 1 over sine theta, secant theta equals 1 over cosine theta, cotangent theta equals 1 over tan theta. All right, this is very important. It needs to be memorized. However, it's not hard to remember. You just got to remember to associate cosecant and sine and associate secant and cosine. The way I do it is we've got the CS and the SC go together. That's how I remember it. Tangent, cotangent, that's not hard to remember. But you've got to remember that cosecant is the reciprocal of, or 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. So you have to know that. So put a star by it and make sure you memorize it. Example 5, find each function value. Alright, so in part A, need a different color. Okay. We want to find tan theta given that cotangent theta equals 4. Well, we know that tan theta is equal to 1 over cotangent theta. That's equal to 1 over 4. That's it. The answer is 1/4. It coming right straight from my identity up here. This one. Well, I guess I wrote it a different way, but hopefully it's clear to you that cotangent equal to 1 over tangent can also be stated as tangent equal 1 over cotangent. That's the same thing. Alright, part B. Secant theta. We have to find secant theta given that cosine theta is equal to negative 2 over the square root of 20. Well, we have that secant theta is equal to 1 over cosine theta. So we can say it's 1 over, and then we've got to put this into the denominator, negative 2 over square root 20. You do have to understand basics of working with fractions. So that's 1 divided by this fraction, which means you're doing 1 times the reciprocal. So square root 20 over negative 2. And this can be simplified as the square root of 20 is 2 times the square root of 5. We talked about that a little earlier, over negative 2. And that simplifies to negative square root 5. That one was not difficult, as long as we knew our rules, our reciprocal rules. Signs of trig functions. Okay, this page, this whole page, mark it, is extremely important. However, this part down at the bottom, once you understand what it says, is the part that you really need to take away from it. So let's talk about this page. This is absolutely crucial to basically the rest of the semester. Signs of trig functions. When are they positive and when are they negative? In the definitions of the 6 trigonometric functions, r, or radius, is undirected. So, in other words, radius will always be a positive value. The signs of x and y are determined by the quadrant that they fall in. So if you're in quadrant, I've just kind of organized information that you already know from basic algebra, but we have to just kind of connect the dots. So when you're in quadrant 1, wherever you are in quadrant 1, the x and the y are both always going to be positive values, because you're over here in the positives with the x's and you're in the positives with the y's. Since the x and the y are always positive, then sine, cosine, tangent are all going to be positive, as well as the reciprocals. So, and you can play around with this if you need to understand it, but let's say you take an example of maybe you've got maybe you've got a point, maybe you've got an angle theta, and it has the point order pair 2, 3. Okay? If you do sine, then you're doing y over r. So positive over radius is always positive. So you get positive. If you do cosine, you've got positive x over r, which is positive. So cosine's positive. If you're doing tangent, you're doing y over x. So you're doing positive 3 divided by positive 2. It's always positive. So all trig functions are always positive if your angle is in the first quadrant. Okay? If you've got an angle that's in quadrant 2, over here, the x values are negative, the y values are positive. That means that when you do sine, you do y over r, so you're doing a positive value over radius, which is going to be positive. All right, sine is the only one sine and cosecant are the only trig functions that will be positive if your angle is in quadrant 2. This is the part that you're going to have to memorize. Okay, so if your angle is in quadrant 1, so you still got, they're all in standard position, so you've got the initial side on the x-axis, the terminal side. If it's in quadrant 1, all the trig functions are positive. If you're in quadrant 2 for your angle, then sine is positive, and since cosecant is the reciprocal of sine, it's going to follow the same rule. But all the other ones are going to be negative for any angle that's in quadrant 2. Now, if you've got an angle that's in quadrant 3, so now let's say I wish I had a pencil, but let's say you've got initial side at the x-axis, and now you're down here, and maybe you're at 220 degrees down here somewhere, so like 220 degrees. This time you're in quadrant 3. X and the y's are all going to be negative in quadrant 3. Okay, if the x's and the y's are both negative, then the only trig function that's going to be positive is going to be the tangent, because that's y over x. So negative over a negative would give you positive. So if your angle is in quadrant 3, tangent's positive, and since cotangent is the reciprocal, it's also positive. But they're the only ones. All the rest are negative. So maybe put in a note here that all other trig functions are negative. Okay, and you can put the same note up here. All the trig functions except the sine and cosecant are going to be negative in quadrant 2. If you're in quadrant 4, okay, if you're in quadrant 4, your x is positive, your y is negative. So if you look at all the trig functions, the definitions, only the cosine and then its reciprocal secant are going to be positive. All the rest of them are negative. All other trig functions are negative. Okay. Now, I know that's a lot to remember. Okay, so we've got a way to kind of tie it together. If you go back and look up what we've done, we're going to start with quadrant 1 and go around. So at quadrant 1, they're all positive. Okay. Quadrant 2, sine is positive. Its reciprocal, of course, is also positive, but everything else is negative. Quadrant 3, tangent, as well as its reciprocal, are positive. Everything else is negative. In quadrant 4, cosine with its reciprocal, secant, is positive. All the others are negative. So we've got ASTC. So we can make up a silly little sentence, or phrase rather, all silver teacups. Okay, so that's going to help us remember that an angle in quadrant 1, so you got to remember it's going 1, 2, 3, 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. An angle in quadrant 1A, they're all positive. All the trig functions are positive. An angle in quadrant 2, remember the S, all silver teacups. So your angle in quadrant 2 is going to have positive sine and cosecant. All the rest are negative. An angle in quadrant 3 has a positive tangent and a positive cotangent. All the rest are negative. An angle in quadrant 4 has a positive, remember the C, has a positive cosine and a positive secant because it's the reciprocal. All the others are negative. Okay, so take the time that you need to grasp this because it's extremely important. It's not hard to remember. You just got to remember all silver teacups. Those are the positive ones. The rest of them are negative. And of course, the reciprocals go with the original. So you've got to remember that sine. You got to remember that cosecant is the reciprocal of sine. So it's going to have the same positive, negative values. Cotangent, since it's the reciprocal of tangent, will have the same sine values as they'll have the same positive versus negative. And of course, secant is the reciprocal of cosine, so they're going to have the same positive versus negative sine values. But take the time that you need to remember all silver teacups. Okay, I hope I've explained that thoroughly enough. Make sure that you spend the time that you need to understand what I'm saying here. And that's going to be super, super important. And we're ready to look at example 6. So now we get to apply what we just discussed. In example 6, determine the signs, in other words, positive versus negative, of the 6 trigonometric functions of an angle in standard position with the given measure. So in part A, we've got 54 degrees. So let's draw the picture. We need to draw the picture so that we can determine which quadrant we're working with. And that will give us the answer that we need based on what we just, that are all silver teacups. A 54-degree angle, what quadrant will that fall in? Okay, well, we know that this is 90 degrees. 54 is going to be in here somewhere. So we're going to be, this is quadrant 1. Okay. If I'm in quadrant 1, I know that all trig functions are positive. Okay, so it's going to be positive. So A is positive. Let's see, it said to do it for all 6 of them. So I guess we're supposed to say sine theta positive, cosine positive, tan positive, cosecant positive, secant is positive, and cotangent is positive. That's what they want there. Part B, 260 degrees. Where is that one located? All right, you got to keep in mind that you're starting at 0. This is 90 degrees. That's 180. This is 270, and then that would be 360, which is the same as 0. So 270 would be this one. 260 is right before we get there, so it's like that. That puts us in quadrant 3. Okay, we know that in quadrant 3, we do all silver teacups. In quadrant 3, it's only the tangent and the cotangent functions are positive. So tangent is going to be positive. Cotangent is positive. And we can say all others are negative. And that's good enough. In fact, in part A, I could have just said that they were all positive. Okay. In part C, we've got an angle of negative 60 degrees. So let's draw this one. What does the negative mean in terms of the angle? Negative 60 degrees, remember that tells you that you're no longer going in that counterclockwise motion. You're starting at the x-axis and you're going in a clockwise motion if it's a negative angle. So negative 60 degrees is going to be about right there, like this. That's negative 60. So the important thing is that this puts us in which quadrant? We are in quadrant 4. If I'm in quadrant 4, which trig functions are positive? You should be able to do this by now. All silver tea cups. C, that's cosine. Cosine is positive. What is the reciprocal of cosine? That would be secant is positive. All others are negative. Okay, and that's the answer. Example 7, let's look at it. Identify the quadrant or possible quadrants of an angle theta that satisfies the given conditions. Okay, so I think all silver teacups is going to help us with this. In part A, I'm going to go ahead and draw it. All silver teacups. In part A, we're told that the tangent is positive. So that means it's either going to be quadrant 1 or quadrant 2. Because tangent is positive in quadrant 3. I'm sorry, I said that wrong. If tangent is greater than 0, that puts us either in quadrant 1 where all the trig functions are positive, or it puts us in quadrant 3 where only tangent and cotangent are positive. So we've got that much. We've got it narrowed down to quadrant 1 or quadrant 3. Also, cosecant is negative. So what does that tell me? If cosecant is negative, that's the same as saying that sine is negative, because it's just the reciprocal of sine. When is sine negative? Sine is negative in these two quadrants. Okay, because they're all positive in quadrant 1. Sine is positive in quadrant 2. And then it's negative in these. So if so we started out by looking at these two quadrants because tangent was positive. Now if sine is negative, that would eliminate quadrant 1, and it just leaves us with quadrant 3. Okay, part B. Draw a picture. If you need to write in your quadrants, do that. But we're going to do all silver tea cups. That's quadrants 1, 2, 3, 4. Now, sine is positive. Where does that put me? Well, it might be in the first one because they're all positive there. Sine is also positive in quadrant 2. So it's between these two quadrants. These are the only choices. Cosecant is positive. Well, cosecant is the reciprocal of sine. So that's really telling me the same information that I had here. Sine and cosecant are both positive, so that's going to put me in quadrants 1 or 2. But that's all. So quadrant 1, quadrant 2 are my answer. Quadrants 1 and 2. And that's it. So hopefully you're still with me at this point. Big concepts that we've talked about so far, of course, is this all silver teacups and knowing how your trig functions are defined. So you've got to have that. You've got to remember sine is y over r, cosine is x over r, tangent is y over x, and then you've got to know that cosecant is the reciprocal of sine, and secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So if you know that, and you know the all silver teacups, if you're grasping what we're doing here, so far so good. Like I said, section 5.2 is a little on the long side, so we still got some more to go. I'd say we might be about halfway through. Alright, next thing, ranges of trigonometric functions. So ranges are important because we're going to be using another type of function called an inverse function to help us solve some of our problems. But they only apply if our theta is in the range of whatever trig function we're working with. So we need to know a little bit about the ranges. Graphing is something that we will not talk about until I think in chapter 7. However, you should have a graphing calculator, and it's not difficult to graph these trig functions. So we're going to look at their graphs and then we can determine the range of the function based on the graph. And that way we've got a way of understanding how we're getting these range values. To get a good visual of these graphs that we're wanting to look at, we need to make sure your calculator is in radian mode. We'll discuss, I was planning to explain to you a little bit later how to convert between degrees and radians, but we'll do it now. On your calculator, you need to find your mode button, which is right beside second. So right here, press mode. Scroll down and make sure that this is in radians. Make sure radians is selected. Mine was in degrees, and that's why I couldn't see my graph very well. I need it to be in radians, so highlight that and press enter. And now we'll go back to our graph. So before I hit graph, I'll go back to y equals so you can see what we've done. We've got the sine x function. Our calculator is in radian mode. And now we'll press graph, and we can see what the sine function looks like. We're interested in the range values. In other words, how high up does this graph go and how low does it go? And to help us with that, we can press the trace button, which is right here. When you press trace, you'll see x and y values along the bottom. And as you arrow, so right now it's flashing at the origin. If I arrow over to the right, I'm interested in how high my graph is going. Looks like it reaches around y, the y value at that peak is 0.9913, so that's very close to 1. And actually, if I could do it perfectly, it actually would be at 1. So I've got a little peak when y equals 1, and then if I scroll over, I have a valley when y equals -1. And you can keep doing it. You'll see how it does the same thing over and over again. It's going to go back up to 1 on the y values. And then if you could continue to see on the right side, the next peak would be at -1 on the y. And you can scroll over to the left and see it over there as well. So if I scroll to the left side, this little valley happens when y equals -1. Hopefully you can see the same thing on your calculator. I don't know how well it's showing up on my screen here. But on your calculator, just play around with that. And by using the trace button, making sure that your calculator is in radian mode, you should be able to see how you can generate the graph that I've drawn in your notes. And of course, the range values, all of these little peaks are at y equal 1, and all of these valleys are at y equal -1. So that gives us a range of -1 to +1. Now, you could do the domain as well, but it's not the domain that we're really concerned about right now. If you wanted to do the domain, of course, these are actually arrows, so it goes from -infinity to +infinity on the domain. But the range is -1 to +1 for the sine function. Okay, and then we did the cosine function, so let's look at that one. Go to y equals, and we'll just replace sine with cosine of x, and graph. It looks alike. It looks similar. I'll let you think about what the differences are between the two. If you go to trace, look at the peaks. You can see that this is, as soon as I hit trace, x equals 0, and it tells me that y equals 1. That's the peak. So y equal +1 is the highest value that this graph will reach, and the valley occurs at -1. So the cosine function and the sine function, they both have the same range from -1 to +1. All right, and then on the next page, I said that from the graphs obtained from a graphing calculator, we find the following ranges. So let's just kind of do these together. Let's do tan theta. So go to y equals, replace cosine with tangent. And you can put x here, that's fine. Graph. Okay, you see the graph looks a lot different this time. It looks like a bunch of x cubed functions. You remember your x cubed functions from 171. That's what these look like. It looks like a bunch of x cubed functions. However, the range values would go from -infinity to +infinity. Let's look at the cotangent. If we do, how do we do cotangent? Remember, that's 1 divided by tangent. There is no cotangent button on your calculator. There's no cosecant button. There's no secant button. But you can use your reciprocals to find them. So we know that cotangent is 1 divided by tangent. So we're going to do 1 divided by tan x and graph. And when you do that, you're going to see what looks like a bunch of negative x cubed functions. And the range is still negative infinity to positive infinity. Let's do secant and cosecant. So let's look at the notes. So I stated in the notes that the ranges of tan theta and cotangent theta are both negative infinity to positive infinity. The ranges of secant theta and cosecant theta are this interval negative infinity to negative 1, union 1 to infinity. So let's see what's going on with those two. How do we graph secant? To graph secant, you're going to do 1 over cosine. So go to y equals, and you're going to do 1 divided by cosine x and graph. And you can see the graph of secant. You can see how this time it's like a, as you would expect, it's the reciprocal of cosine. Remember, the cosine was revolving around the x-axis. The secant function is above and below the 1 and the negative 1 that we found for our range. So if you were to hit the trace button on these, you can see that this valley occurs when y equals positive 1. And if I wanted to see one below it, how do I get there? I don't remember. There's a special button I need to press to get down there. There it is. Okay. I just arrowed over until I found it. Here my peak is y equal negative 1. So this is how I'm getting my range for my secant function. The range is negative infinity to negative 1, union positive 1 to positive infinity. And the cosecant graph is very much like this one. I'll let you play with that yourself. But hopefully you see how I got my range values. Secant and cosecant have the same range, negative infinity, negative 1, union 1 to positive infinity. So we need these ranges to help us answer example 8. And we need to understand them anyway. So let's see where this is all organized for you in the textbook. I didn't put it all together in a table, however. But so let's look at these. We've got sine theta equal 2.5. So remember, the sine function looked like this was the sine function here. Is it possible for us the sine of some value to give us 2.5? Well, that's a y value of 2.5, which is way up here, and that's not on the graph. So this 2.5 is not in the range of sine theta, so this one's impossible. Tan theta equal to 110.47. All right, now my first thought is, did I copy that correctly? So let me double check. Yes, I did. Okay. Tan theta 110.47. Well, remember, what was the range of the tan function? If you don't remember, you can come back over here, press y equals, press tan x. I need to clear out the old one. Okay, remember the tan function passed through the x-axis like a bunch of x cubed functions. So this range was negative infinity to positive infinity. So it's okay to have a large value for a tan function. Tan theta equal to 110.47 is definitely possible, because its range was negative infinity to positive infinity. Part C, secant theta equal 0.6. Is that possible or impossible? If you can't remember your range, go to y equals, clear out the previous one. You have to remember that secant is 1 over cosine. So 1 divided by cosine theta, or x on your calculator, graph. Okay, so the range on this one was negative infinity to negative 1, union positive 1 to positive infinity. So this 0.6 is not in the range. 0.6 is going to be in between these peaks and valleys. It's in between them, so it's not in the range. So the 0.6 would be right here in the middle somewhere. So secant theta equal 0.6 is impossible. Okay, so again, if there's something you're not grasping, ask me about it in class. Put a note in your margin so that you will remember.